Hi there, I'm Fred Cupp, and I've been a model railroader since 1956 or so. Obviously I'm one of the old timers, so I've also been an old timer as far as DCC in model railroading is concerned. I was originally a member of a club up in Rochester in which Jim Scorse, the president of North Coast Engineering, was also a member, and I was present at the first demonstration of DCC in had to be in the 80s, someplace back in the 80s. I forget the exact date, but at any rate, there's a lot been going on since then in the DCC world. If you were into DCC, you know most of the things already that can be done. One of the recent things to show up on the market is NCE's mini panel. A mini panel is a memory device which has 30 inputs, and each of those can be associated with a block of memory or commands to do certain functions on your model railroad. Anything that can be done with the throttle, the big throttle on the NCE system, you can do all of the same things with the mini panel. And that includes throwing switches on your layout from the mini panel. You can select locomotives, you can change their speed, you can blow the whistle and ring the bell. All of these things are possible using the mini panel. The mini panel does these functions in response to a happening on any of the 30 inputs. A signal that may be a contact closure, a photoelectric cell, or a voltage change on some detector will trigger the action that you desire. So it's limited by, first of all, your imagination, and secondly, it's limited by your ability to fight your way through the somewhat puzzling programming method of storing the information in the mini panel, which will then follow the routine that you have planned out. It takes a lot of planning. You have to know what you want to do, and then you have to live within the limitations of the very small programming language that the mini panel uses, so that you can duplicate the commands of the normal throttle. So,
hello, I'm James Ingram for AutoControls-dot-org. The subject of this video is a quick demonstration of the NCE mini panel. We're at the Toy Train Expo in Williamsport, Pennsylvania, November 2010. And this is just a little display layout that demonstrates the North Coast Engineering NCE mini panel, which allows you to do rudimentary automatic control using the North Coast Engineering DCC system. And basically what this layout is here, it's 3 gauges. There's a N gauge loop on the inside, and there's an S gauge loop outside of that, and then going around the outside is a large scale point-to-point layout. So basically this little layout demonstrates how the mini panel can control these 3 different scales of trains. And actually, as you know, anything that's got a standard NMRA decoder in it will respond to the mini panel. It's handy because Let's see if we can start the N-gauge train first. Fred Cup wired up 10 buttons. I'm just using the button connected to input 1, which activates a part of the program that starts the N-gauge train. This will ramp up to a steady speed, cruise for about half a minute. It'll blow the horn, and then immediately it'll start slowing down after that. There's the horn. Now it'll start slowing down. This engine has no sound. There's actually a sound unit in that blue plastic box. It's just to the left of the command station, actually between the command station and where the engine's parking. It's got a sound decoder and a speaker in it, again courtesy of Fred Cup. Now in a minute the N-scale sound will switch off, which it did, and the S-gauge train will start up. This train will start up in reverse. It'll cruise in reverse for about 30 seconds. It'll blow the horn. Immediately after it stops blowing the horn, there's a wait statement that's waiting for an electric eye to be activated. The electric eye is in the rear of the layout. You have to put a delay statement in. There goes the horn. Now the next time the train goes over the electric eye, which is back in the rear, it'll activate the program to start slowing the train down. There it goes, slowing down. It'll sit here for a few seconds idling, and then it'll start up and forward and go through the same sequence. As I started to mention before, you need to put a delay statement in so that it travels around a couple times. If there was no delay statement, it would stop the next time it came to the electric eye before it really got started. So I put a delay statement in. It makes it travel 2 or 3 times around the loop. Now the horn is blown, and now when it comes to the eye, which is right about here, it'll activate the mini panel to slow the train down and hopefully stop somewhere near the station. This S-gauge train will idle for a minute, it'll shut off, and it'll activate the LargeScale engine, which is sitting over there behind the, back in the rear. This train's running point to point, so Once it blows the horn, then it's looking, again, there's a wait statement. It's looking for a reed switch this time. There's reed switches in the track at each end of this semicircle. So when the engine goes over a reed switch, the magnet on the bottom of the engine will activate the reed switch, and the mini panel will slow the train down. Switch, so it'll sit here and idle for a minute, and then it'll start back up in the reverse direction. Again, there's a delay statement between when it starts up and when it blows the horn. After it blows the horn, then it comes to the wait statement for the reed switch. That engine will park and idle for a few seconds, it'll shut off, and then the mini panel will loop around and start the same sequence over. Now you can see the N gauge train is starting up again. And this sequence will keep happening all day long as nothing malfunctions. The N gauge train will run, then the S gauge, then the large scale train. I need to acknowledge thanks to Fred Cup for getting me started on this mini panel. Without his assistance, I don't think I could have gotten going. There is a technical reference manual and instruction manual in PDF format on the NCE website you can read, but about half of it goes totally over my head. But with Fred's help giving me some examples and showing me how to operate it, I was able to get going with this system. What I've done here is fairly basic. I'm sure there's much more elegant and efficient ways to use this mini panel. This is just a demonstration of one way you can use it to control trains automatically. Looking at this system, this is the North Coast Engineering NCE Digital Command Control DCC command station, which you normally use for controlling your DCC trains. This unit right here is the mini panel, which connects to the cab unit. This button here is just a reset button, which allows you to reset the unit. This thing actually is programmed using the ProCab throttle, and when it's in operation like it is now, it acts essentially, as far as I can see, like another throttle. You could be controlling things with a throttle or multiple throttles on your own, and this thing would be automatically sending commands. You could think of it as another throttle with a robot operating the throttle on your layout. That's essentially what it's doing. The primary purpose of this thing, according to NCE's website, is like for yards and interlocking. A secondary purpose they set it up for is rudimentary automation, which is how I'm using it now. I'm going to power up the system right now. When this thing sends a command, there's an LED, a red LED right here where I'm pointing with the pen. When the mini panel sends a command, that LED will blink. That tells you it's sending commands. This is the reset button. If I push the reset button, you might be able to see that the LED blinks when I push the button. Now if I push button number 1, which controls the N scale, which starts the N scale train, you can see it blinked and eventually the N scale train starts up. I've got about an 8-second delay just to allow the sound unit to settle down on the N scale. You program this mini panel by using a ProCab throttle. Right now the thing is in basically, I guess you call it operate mode. It's set up and it's running basically like another throttle on the layout, except it's a throttle that controls itself using the commands you put into it. This jack connects it to the command station. This is another jack that anybody can use to hook another throttle into the system. However, if you hook the ProCab into this port over here, which is the programming jack, then when it comes up, this thing will be in the program mode as opposed to run mode. So basically you have a program mode when you've got the ProCab plugged into the program jack, and you also can put it into a test mode, and then when you take this away or move it over to the normal jack, it's in run mode. This mini panel has about 30 inputs on it. You can use, that is to say, you can put about 30 different inputs like reed switches, electric eyes, or toggle switches or other things. Fred Cupp, when he set it up, wired 10 push buttons up to it and inputs 1 through 10, which is what you see here on the right. Back here is the electric eye in the S-gauge track. So when the S-gauge train goes over that electric eye, when the program in the mini panel is the right point, it'll detect the train and start slowing it down. The N-gauge has no detectors in the track. It just ramps up and runs for a predetermined amount of time, like 30 seconds, and then ramps back down. The LargeScale train has reed switches in the track. Swing around to see those if we can. Right down here where the tape is, that's a reed switch. It's in the track, and there's another one over on the far side, just to the right of where the D&H bear is sitting. There's a reed switch in the track there underneath the gondola, and a magnet on the bottom of the loco on the LargeScale activates the reed switch, which tells the mini panel to slow the train down so it doesn't run off the end of the track. Here's one of the electric eyes, which was like used on the S-gauge. Fred Cupp got this for me. It actually comes, this part of it here, the short part, from like a mail-order electronics firm, I believe, like Mauser or DigiKey or one of those type of firms. And Fred soldered these extra wires on it, so it's about 3 foot of wire on it as it is now. There's no electronics associated with this. You just basically have 2 ends to the thing, and one end gets hooked to the, you hook one end into the ground of the mini panel, and you hook the other end into the input wherever you're going. For the S-gauge, I think I used input 11. So I'm pretty much of a klutz with these electronics, so I was kind of nervous putting this on the S-gauge, but I basically drilled a hole in the wood and stuck it in and wired it up, and it works. So one more thing to mention, and this is printed off the NCE website. This is the menu of what you can program into this thing using the ProCab to program it. Some of these I've used, and some of them I don't. Like here's your loco selection things. You can select the loco number, which we've used here, select the speed, and select functions on the loco. you can do F0 through F4 in one batch, or F5 through F8 in another batch. Basically, you have to send these. It's not like you push a button individually, like when you got a ProCab in your hand. You have to send these in a group of 4. As you may remember when you see me review these, you've got to send all 4 of these however you want them. And there is a way you can access above function 8, but it's not simple. They talk about that in the manual, and I don't even understand it, to be honest. And you've got other things you can do here. Here's your delay statement. Again, they give you either select a 4-second delay or a quarter-second delay, and you can select just about any number of these. So, like I use quantity 4 4-second delays and quantity 8 of them, but that's how you cause a delay to happen. And over to your wait statement, you can wait for a ground. That would be like either a button or a reed switch, where when you activate it, it essentially goes to no resistance, ground, or wait for an open, which is how an electric eye works. And I'm sure there's many other things you can hook up to here also that I'm not familiar with. Here's your link statement, like link to another input. And again, this is if you program the BASIC or COBOL or Fortran, this is like similar to a go-to statement. Add a no-op, that's basically if you want to just fill a space with nothing, but if you want to think you may want to later add a statement in there and just want to have an empty space, you can have a no-op, which is do nothing. Skip commands, I don't use this. This is more advanced, and they discuss this in the manual. Terminate just means end. If you put a terminate statement in, it'll just stop there. So these are some of the commands you can program into the mini panel using the ProCab. I mentioned earlier I write all these commands down in a Microsoft Word file before I actually start programming anything into the mini panel. And a reason for doing that is you can't really move commands up or down. To explain that statement better, if you've ever programmed in like BASIC or Fortran or COBOL or Pascal or whatever the newer languages are, if you want to insert a line of code in a computer, you just insert it. Well, you can't do this thing. When you put it in a certain input, like if you can see, I happen to be looking here at input 16, step 1. If you want to insert something in there, you can't do it unless you happen to have a no-op statement that gives you an empty line. You have to actually redo all this programming to move things down. Saying the same thing another way, to get your command slid down a couple lines, you have to actually redo the programming all over. There's no way to just insert a line like you would on a computer, so that's a limitation of the mini panel. Again, made up for the fact that it's cheaper and simple to operate. You don't really need a computer to run it. So there's trade-offs. You're getting an inexpensive device that you can use without a computer, but your programming's a little less flexible. Okay, I've got this ProCab hooked into the programming jack on the mini panel, and I think we can actually read the screen a little bit if I hold it just so. I'm going to put this into review mode. You can see we got a choice of 3 things to do. One is setup, where you actually put program commands into this mini panel. 2 is where you can review commands, and 3 you can test a thing. If you use the test mode, it actually executes commands that you programmed into the thing. I'm going to push 2 to put it in review mode. I'm going to tell it to input to review starting at input 27, which is where the engage commands are, which are the simplest. I'll hit the enter key. Now we can step through these commands. You can see inputs 27. Step 1 says select loco 16. That's the Engage Delaware and Hudson PA unit parked back there. So select loco 16. That turns on the sound. Function 8 is often used to turn sound on and off for sound decoder locomotive. So the 8, it says turn function 8 on. All the others are off. Now, you have choice of two types of delays, a 4-second delay or a 1/4 second delay, and you can program just about any number of those. So I selected the 4-second delay and said give us 2 of them, so there's 2 4-second delays, so that basically delays for 8 seconds, and that's just to let the sound settle down. Now, this turns on function 0, which is a headlight, and function 1, which is the bell. So this will start ringing the bell. Now, select the speed forward 12. This starts the locomotive running. I've got a fairly good amount of momentum, I think set to about 15 on the N-gauge locomotive, so it'll ramp up the speed fairly slowly. Again, another delay statement, 8 seconds, so this will basically ring the bell for 8 seconds. Now this next command keeps the headlight on, but function 1 you can see is turned off, so that turns the bell off effectively. Again, another delay. Here we've got 8 4-second delays, so this is 32 seconds total. This allows the engine to continue ramping up the speed, and it cruises around the loop the circle of track a few times. Now there's function 0 is still on. That's the headlight. I keep that on all the time. Function 2, that's the bell. Excuse me, that's the horn. That blows the horn. So I'm turning on basically function 2 to start blowing the horn. Again, a 4-second delay, so that keeps the horn blowing for 4 seconds. And the next command turns the horn off. You can see the 2 function is turned off, which turns off the horn, but function 0 is still on, which keeps the headlight on. Now we say speed forward 0, so that starts the locomotive ramping down. Again, with its momentum, it'll cruise around the track a loop or 2 as it gradually slows down. And now a 4-second delay, 8 of them for a total of 32 seconds. That allows the engine to gradually slow down and come to a stop. Now there's a link statement. It says link to input 8. And what input 8 is, I won't go there, but that sends a couple, about 3 commands to turn the sound unit off. That happens to be an MRC sound unit. It has sort of a weird sequence to turn it on, turn it off. You got to push the F8 button about 3 times if we're using the Pro Cab, and it's tricky when you're using the mini panel, but I found sending, I think, an on and an off and an on, or the other way around, maybe an on and off and on, whatever, I can get it, after much flailing, I can get the sound to turn off. It's a little bit cumbersome. But that's basically reviewing a set of inputs for running the N-gauge train. Now we're going to take a look at the statements used to program it to operate the S-gauge train, and that's on input 14, I believe. So we're going to, again, push 2 to select review, and then we're going to say, we're going to type in the number 14 to tell it to review input 14, hit the enter key. So input 14, step 1 says select loco 452, and 452 is that S-gauge SW9 diesel sitting back here. So we've selected that loco. Our next step, function 6 on this S-gauge engine turns on the rooftop strobe light, and it also happens to turn on the sound. In theory, you should be function 6 and 8, but there's a quirk in this decoder that if you do both of those, the sound turns back off. So again, I found by trial and error, this is how you turn the sound on. This is like a early generation soundtracks decoder. All these decoders have their own little quirks, so you can't program one quite the same as another, even though in theory they ideally should. You have to try to work around the quirks of each decoder, it seems like. I like these engines with the strobe lights. Being a true tin plater, I like to have, when the engine is sitting still, if you've got sound and you've got the strobe light on top of the roof, it looks like your engine's doing something even though it's not moving. So that's why all my engines in very unprototypical fashion have strobe lights on top of the roof. Okay, going to step 3, we're going to delay, we've got a delay of 4 seconds and a quantity of 2 of them for a total delay of 8 seconds. That's, again, just to let the sound kind of settle down when it's turned on. Okay, there's function 0. That turns the lights on. Function 1 turns on the bell. Speed in reverse 10, so that starts the engine running in reverse. Delay, a 4-second delay, a quantity of 2 of them for a total of 8 seconds delay. We're going to ring the bell for 8 seconds. Now our next statement turns off the bell. That was function 1, but function 0 we keep on because that's the headlight. Step 4, we've got a delay 4 seconds, quantity 8. That's 32 seconds. That just lets it get up the speed and run around the loop a couple times, because there's the electric eye that it's looking for to slow down is back right behind the front of the caboose. Back here is the electric eye, so if we didn't have a delay statement, it would hit the eye and slow right back down before it really got going. So we put the delay statements in to basically have it ignore the electric eye till it gets going. Now this statement turns on the horn. That's function 2, turns on the horn. 0 keeps the headlight on. Delay 4 seconds, quantity 1. It's going to ring the it's going to blow the horn for 4 seconds. Now we turn the horn off. Keep function 0 on because we want the headlight to stay on. Now we're going to wait for input 11 to go open. This works almost like a reed switch, except instead of saying ground, you say open for an electric eye. And again, all this smarts is courtesy of Fred Cupp. But there's electric eye back there, and so next time this train hits the electric eye, I should say next time it goes over top of the electric eye, this statement will be executed, and it'll go on to the next statement, which says speed 0, which will start the train slowing down. Now it says delay 4 seconds, quantity 6. It's going to sit there for 24 seconds, just idling. Now it's going to turn on the bell again. That's why we turned on function 1, kept the headlight on with function 0. Say speed forward 10. We were running reverse a minute ago, so now we're going to go forward, speed 10. Delay for 8 seconds total. That's to keep the bell ringing for 8 seconds. Now we're turning the bell off. Function 1 disappeared, but function 0, the headlight, we're keeping that on. Now we're going to delay again, a 4-second delay, a quantity 8 for a total delay of 32 seconds. That's just to let the thing get up to speed and go around the loop a couple times before it stops, before the electric eye causes it to slow down. Here we're blowing the horn. We turn function 2 on, which is the horn. Delay 4 seconds, quantity 1. That's a 4-second delay. We're going to blow the horn for 4 seconds. And here we're turning the horn off again, but keeping function 0 with the headlight on. Now we're waiting for input 11 to go open, and that's that electric eye back there. Next time it crosses the electric eye after the horn blows, this statement will be executed, and we'll go on to the next one, which is speed 0, which will start it slowing down. Again, we have a 4-second delay, a quantity of 4 of them, total of 16 seconds to slow down and get stopped. A no-op statement, which is do nothing. Now with this statement, we're going to turn off the sound. That function 8, you'd think that would cause it to turn on if it behaved like it ought to, but I found, again, by a lot of fiddling around and trial and error, if I send a function 8 command by itself, it'll turn the sound off, even though theoretically it should do the opposite. Just, again, a quirk of the decoder. A no-op statement. Now it's proceeding into the next block of code, engine 760. That's the large-scale engine. So you can use, if these things happen to be programmed in order, you can just go from one set of statements to another. If they're not in the order you want them to execute, you can use a link statement, almost like a go-to statement if you've ever programmed in BASIC or Fortran or something like that. The review mode on the ProCab. Again, we got the ProCab plugged into the setup jack on the mini panel over there, so we have the option of doing setup commands, reviewing commands, or testing operation. Again, we're going to push 2 to go into review, and it wants to know what input, and I'm going to review input 21, which this time is the the large scale, so we enter 21, it should say we type in 21 using the numbers, push the enter. Okay, now we're at input 21, step 1. It says select loco 760. That's that large scale Santa Fe GP9. It's parked back there on the rear of the layout. And push enter to go to step 2. We've got functions 0 and 1. 0 is the headlight and 1 is the bell. And that does nothing on this loco because the loco doesn't have a bell. The lens decoder that's in this loco doesn't have a bell, and the headlights are malfunctioning for some reason. They're not coming on. But that, if I had a bell and had a headlight, that would turn them both on. There's function 8. That turns the sound on. Again, a 4-second delay, quantity 4 of them, so that's 16 seconds to let the sound settle down. Speed forward 18, that'll start the engine moving. Again, another delay, a 4-second delay, a quantity of 4 of them for a total of 16 seconds delay. That's just to get the engine rolling and let it get partway around the layout. Now there's function 5 on this engine. This is programmed, this is a lens decoder, and they don't use quite the standard NMRA decoding who programmed this. Function 5 turns on the horn. Actually, this engine has 3 horns, but function 5 turns on one of the horns, and function 8 keeps the sound turned on. Delay, here's a 1/4 second delay, 8 of them, so that gives a 2-second blast of the horn. Now function 5 has been turned off, which turns off the horn, and function 8 keeps the sound on. So now we're doing a wait on input 13 to go to ground. The reed switch that the engine is heading toward is hooked into input 13, and when the magnet on the bottom of the loco goes over top of the reed switch, that'll go to ground. In other words, it'll transmit current, and this statement will be executed, but the thing will be sitting here waiting for this to be happening until that engine gets to the reed switch. And this is one thing they caution you, if you're doing other things with this panel, this type of a statement sort of ties it up till the engine gets there. So if you were depending on other inputs being executed, the panel could miss them because I've got it tied up waiting for this one to happen. Okay, when it goes over that reed switch, it'll move to the next statement, which is this one, input 23, step 3, speed forward 0. That'll stop the engine, and again it has some momentum, so it'll kind of coast to a graceful stop at the end of the layout. And that's actually right here. This is the reed switch down here, and the end of the track, as you can see, is right here. So the engine will coming this way, left to right, it'll go over the reed switch and coast to a stop, as you'll hopefully see on the other parts of the video. Okay, we got a delay of a 4-second delay, a quantity of 3 of them, so that's 12 seconds. So basically the engine will sit there and idle for 12 seconds with the sound and the rooftop strobe light on, but basically idling stationary. Speed reverse 18, so that'll start the engine up traveling reverse to go to the other end of the point-to-point layout. Again, delay 4, quantity 4 of a 4-second delay, a total of 16 seconds delay to let it get going for a while. There's the horn. Now this time I'm using function 4, which is another horn. It actually has 2 horns on it, and I'm using a different horn going reverse. Previously I used function 5. This time I'm using function 4 to go in reverse. And 0 and 1. 0 is the headlight, and 1 is the bell, which actually should be off here. Okay, another delay of 1/4 second times 8, that's a 2-second delay. It's going to blow the horn for 2 seconds. Now this statement turns the horn off. That horn was function 4, and function 4 is turned off, so the horn goes off. Again, now we're waiting for input 12 to go to ground. And input 12, remember this is when the train is traveling in reverse to get back to where it's sitting now. Input 12 is right almost behind that Delaware and Hudson bear. They were just behind the big brown bear sitting there under the gondola. is the read switch, which is input 12. So when the loco gets to that read switch, it'll go to, and the magnet activates the read switch. It'll activate the statement. It'll go to ground, and it'll proceed to the next statement. And that next statement is speed 0, so that'll cause the locomotive to come to a stop. We're going to delay 16 seconds to kind of idle there for a minute. A do nothing statement. And that statement there turns the sound off. Another do nothing statement, a no op, and we're done with the G scale. And actually now we're back to input 27, select loco 16. So this has come back to run the N gauge again. But this basically shows the statements that I use to program the large-scale engine to do that point-to-point operation. Again, there's probably better ways and more efficient ways to do this than the way I've done it. This is just one way that an amateur like myself can accomplish that task. One thing they mentioned in the manual, which is important to keep in mind, is when you use delay statements and sometimes the wait statements, it basically has the mini panel, I guess you could say, hung up at that line of code, so it won't look at other inputs. So it may be stuck at one place. You have to keep that in mind. That's why I do a delay when, like for example, when the large scale engine over there starts up, I do a delay statement to get it going for a while, and I blow the horn. I do that fairly early in the process, but when it comes around the track and it's coming down to the end of the track, if it's in a delay statement, it goes over that read switch there, it won't see it. It would crash right into the end of the track here. So I have to make sure it's not in a delay statement, that it's actually actively looking for new inputs.